Welcome back, guys. So we are kind of coming down to the last week of 8th grade physical science. Basically, the way that this week is going to work is it's a lot of assignments that are not necessarily going to be graded, and it's mostly a week. I want you to make sure that everything that is from the last couple of weeks, that you're definitely caught up, that there's nothing that stands out on RunWeb, on Gradebook, that you're like, I don't understand this. What's the deal with this grade? Oh, why is this missing? Please, please, please email me ASAP. And I will get in contact with you and all of that good stuff. But what we wanted to talk about, what I wanted to do for those of you that are caught up but just want something to do, something interesting. Basically, I'm going to make kind of short videos about different topics that you guys had questions about on the test. There was a spot to leave questions if you had any about anything science related. And basically, I'm going to gather some resources as well for you to explore those on your own if you would like to, because I know, at least for me during this time, it's kind of been a time of reflecting, but also a time to kind of explore some new interests. So without any further ado, I'm going to talk a little bit about space. Yeah, that was pretty much the #1 requested topic throughout all of the tests as I'm filtering through them was space. So let's talk about space. Okay, so we call this branch of science that we're starting to talk about, it's called astronomy. Make sure, if you want to sound intelligent, that you always say astronomy and not astrology. Astronomy is the study of celestial bodies and their phenomenon. But astrology has to do with trying to predict the future based on stars and things like that. So basically, the study of the stars, the study of the heavens is something that has been around for a really, really, really long time. And in fact, one of the first notable people to write something sciencey at least, about astronomy is Aristotle, going all the way back to the ancient Greeks. And it used to be that we thought that the universe revolved around Earth. But then we found out through Copernicus, through Galileo, and some of these other important figures, that we have something called a heliocentric model, meaning that the planets orbit, I don't know why I couldn't think of that word, they orbit around the sun rather than other things. So let me write that word for you in case you want to sound super smart and like impress people. It's called heliocentric. And the word for planet in and of itself, I think, gives us an idea about what this whole field of study is. In fact, the word for planet comes from this Greek word, which is planetes, I'm not sure. But it means wanderer. So the idea of looking up and thinking, what is my place in all of this, the vastness of it. Before I go too much further, I wanted to share with you this quote about astronomy in general and why it's kind of a good study for us as Christians as well, because of some of these things that Carl Sagan says. Carl Sagan was not a Christian, but he has some things here that I think could tie into thinking about our place and thinking about just how big our God is. And that is this quote: "It's been said that astronomy is a humbling and character-building experience. There's perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known." And what he's talking about there is this famous image, and I encourage you to look it up. It's this really famous picture of Earth, and it's from kind of a faraway vantage point, and just how small that Earth looks in comparison. It's kind of in like a ray of sun, and it's just so humbling to know that the same God that made such a big universe cares for us on that tiny little pale blue dot. And so I think that's something worth mentioning. So now I'm going to get into some special topics within astronomy and within some specific things that might find interesting. Maybe not. Maybe you will. Maybe you don't. I don't know. And the first one is the moon. Somebody requested specifically that they want to talk about the moon. So let's talk about the moon. Okay, so the moon. The moon has been something that we've looked to, that we based our first ever kind of calendars and how we think about time on, because it is so close to us and because it has different phases based on where it's passing in relation to the sun. Keep in mind that the moon is orbiting around the Earth, and it's orbiting in a way so that the same side is always facing us. In fact, we kind of call that the near side of the moon, which you can see right here. So let's see if my marker works. It's always fun to know if my marker doesn't work at the onset of these things. Let's see. Yeah, it does. Cool. So that's the near side of the moon right there. The far side of the moon, we didn't even know like what it looked like until fairly recently. So that's kind of an interesting little thing, that the far side of the moon actually looks a lot different than what we actually originally thought it was going to look like. So some interesting things about the moon. The moon, you might be wondering, what is the atmosphere like? And this is one of the key reasons why I guess some people, especially if you're into science fiction, you like to think about if we could colonize the moon, if we could do terraforming, which, you know, if you might know from like things like Minecraft or what's the new one that you guys are playing these days, Animal Crossings, all that kind of stuff, about kind of shaping the soil, shaping things like that so that living things could live there. And it's a big question because we're very, very far scientifically from being able to do that, especially on the moon. And part of the reason why is because of the atmosphere of the moon. The atmosphere of the moon is actually quite different from Earth because it basically doesn't exist. The atmosphere of the moon is kind of like a vacuum. So it can hold a little bit, but the reason why it is like a vacuum is because it doesn't have enough mass. The reason why atmospheres exist at all is because of a combination of how massive they are and what kinds of things enter into that realm, that sphere that the gravitational pull can have. So because the Earth is much more massive and it has a core that is a lot more metallic, it's able to kind of draw more things and keep that atmosphere a little bit more closely. We call this, and it's also the reason why, so escape velocity is going to be, if you're launching a rocket ship, it's like the speed that you would need to get it to break through that gravitational pull. So if we were to put a base on the moon, for example, it would actually be a lot easier to launch a rocket from the moon than it is to launch a rocket from Earth, because the escape velocity of the moon is so much lower than the escape velocity on Earth. Other interesting things about the moon. So the moon does not really have some of the same patterns of weather that we see on Earth. Like, for example, earthquakes. We're not really sure about the plate tectonics and all of that kind of stuff, because if you look at the interior of the moon, there's a lot of things that are similar, but the inner core is super, super small, and the mantle is quite large. That mantle is actually thicker on the far side of the moon, this side, than it is on the near side, which is kind of weird. In fact, just some other little things about the moon. So the moon has some different parts on it. You have basically two main parts that we talk about when we talk about the topography of the moon, or the way that the land looks. You would call these higher parts, you would call them the highlands. And basically the entire backside, the far side of the moon, is almost entirely highlands. They could be kind of punctured with craters and things like that from meteors that impacted many, 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 many years ago. And then you have these kind of weirder, kind of flatter, smoother surfaces, which we call the maria. And it comes from the Latin for the sea. So we call those the maria, and those are kind of the main like features that we use when we talk about the moon. The cool thing, and it's interesting that you guys bring this up, is we just recently, if you look down here, this is an actual press release, that the U.S. Geological Survey actually for the first time released a map of the moon, which is kind of cool. So that happened a couple of weeks ago, and you can actually explore that map if you'd like to. It just kind of shows the ranges of all these things of the moon. Another cool thing about the moon, last thing before I move on to something more interesting, I promise, is we have actually determined that there is some frozen water there. In other words, ice. We call it lunar ice. And it's only existing at the poles of the moon because the sun is not there. Otherwise, liquid water actually doesn't really retain its shape on the moon. And the reason why is because of that escape velocity, right? So if there's no atmosphere, then basically, or there's very little atmosphere, that water can basically just escape and at a rate that just isn't favorable. So we can't really have liquid lakes and oceans and things like that. But we do see lunar ice, and we actually confirmed that fairly recently. So that's something that's kind of interesting, especially if you are one of those people that likes to think about, hey, could we colonize the moon? Well, we have ice there, so it's a start. One more thing about why the moon would not be a good candidate for a colony, actually, I forgot to mention this before, has to do with the temperature. So because of that atmosphere problem, we are going to have a major temperature problem as well. So sorry, I'm trying to straighten my camera there. So basically, the range in temperature for the moon, because of that atmosphere that is kind of non-existent, it can range from 260 degrees Fahrenheit at like noon on the moon, or at night, which is kind of like a 2-week period. If you're on the moon, it would be negative 279 degrees Fahrenheit. So look at that range, pretty crazy. And the moon is so close to us, but it still has that huge range in temperature. It's crazy what just that layer of atmosphere can do. All right, so we talked about the moon. Let's also talk about Mars. Mars is probably the one planet that is going to be closest to Earth in terms of just general atmosphere and conditions. It's the last of the terrestrial planets, meaning the ones that are kind of rocky. Those first 4 planets that are smaller and rockier, kind of like Earth. And it's the 4th planet. And it's been something that we've been interested in as humans for a while now, because it has so many unique features and so many that are really kind of similar to Earth. In fact, a lot of people think that Mars would be the next jumping point as far as human exploration goes. In fact, at one point, NASA had said that they wanted to try to get people on Mars by 2030. I would need to look into that. Maybe you can look into that and see where they are as well. But that's one of the things that everybody gets excited about, right? We send these rovers there. But it is kind of a long and difficult journey because it takes a little over a year to get to Mars. So I think it's more than half of our attempted missions to Mars have failed. So it's costly, but it's something that people are interested in because of the conditions. And one of the things that makes Mars so unique is that it has conditions that show that it could have had water at some point in its history. It has minerals that could only be made by having an abundant water supply. There's evidence that it used to be a lot warmer, that the atmosphere used to be a lot thicker. And it has a lot of the organic molecules that we would need for life, all of those polymers that we talked about in the last couple of videos. It doesn't have specifically some of those, but it has the ingredients for them, which is something that scientists are incredibly interested in. So some things about Mars. It's called the red planet. Reason why, because it has that red exterior. And the reason why it looks red is because of the chemical, the element that is making up that dust, which is iron. My pen, I think, ran out of charge, so I'll type it. So it has iron mostly, as well as basalt, which is kind of like a volcanic rock, and those kind of mix together to create its rusty looking exterior, because what happens to iron when it gets put in the oxygen, it gets rusty, right? So that's why it looks the way that it does. It has, in the north, it has kind of like these plains, and it's kind of more like dunes and things like that. Very smooth. And the altitude, if you look at the picture that has the different colors on it where it shows the altitude, the northern hemisphere is actually going to be a lot lower, which is kind of an indicator that something large hit Mars at some point in its history, when you compare it to the rest of its altitude. Other parts, the southern hemisphere is going to be rocky, dusty. Mars does have seasons because it does rotate on an axis, so it does have seasons like we do, and it has also like dust. We call them like dust devils. They're like tornado looking things that can create these really cool and interesting patterns, which is kind of cool. the temperatures on Mars, they are pretty cold because, again, kind of like we said with the moon, if there's not a huge amount of atmosphere there, there's not a lot of protection from the UV radiation. So both on the moon and Mars, we would be prone to UV radiation on intense levels. But also things escape easily, right? That escape velocity is going to be low. It doesn't take a lot of energy to escape that gravitational pull, relatively speaking, compared to Earth. So it's going to be cold, and it's going to be ranging around negative 81 degrees Fahrenheit on average, but it can get lower to some of those temperatures we talked about in the moon, to like the negative 280s, I think. We have a lot of work to go if we wanted to actually make Mars viable. But one of the things that I have, I actually have a college textbook here. And this is a little bit dated. I was in college, a while ago, but not that long. I don't know, somewhere in between. But anyways, this is a college textbook, and it actually does talk about terraforming Mars still. It's still something that everybody's so interested in, but we're still a long way to go. We would have to change fundamentally the atmosphere of Mars if we wanted to actually live there comfortably. But it does have a lot of the other features that we would want and we would need in a planet. So, interesting stuff. So anyways, that's just a quick little intro into kind of space and astronomy for you guys today. I'm going to put some challenges, some different places where you can go more in depth if you are one of the people that are just really interested in learning more about astronomy. I'm going to put those links here. Keep in mind, Monday, Tuesday, and Wednesday, I'm going to have like longer stuff, more like links and things. Thursday and Friday are technically half days, so I'm going to leave that to you to do any extra exploring that you would like to do on any of these other 3 days. And I'll maybe make short videos for weird questions that you put that I didn't answer, because there are a couple of them that I'm like, that's an interesting question, but it doesn't warrant like a whole 15 minute video on it. So anyways, I hope you learned something. I hope you found this mildly interesting. If not, just don't tell me. But either way, it's good to hear from you. It's good to see you. And shoot me an email if you have any questions. Bye, guys.